Hey folks, here is a continuation of sums, but this is going to be significantly more challenging and hopefully interesting. What we're looking at right now is it's just a processing sketch that at first it draws a line and then it draws rectangles underneath that line that go all the way down to the bottom. So here the bottom left corner would represent the origin in quadrant 1 of a Cartesian graph. So basically it would be the bottom left corner of a piece of graph paper. And this line goes up and it's just set right now. I have everything hopefully just at maximum simplicity. And you'll see at the top, I'm going to walk through this line by line with you. And then I'm actually going to ask you to use this code to do your math practice, and I'm going to ask you to modify it so you can actually get some calculus practice. But I'm just going to go through one by one with you. Okay, so float, you see x, y, m, and b. We're going to use those to keep track of all of the variables in our equation for a line later on. And then you see int num rects. That'll be the number of rectangles, and we want to keep track of that for later. Array list is something that may or may not be new to you. Array lists are a way of storing information. We can put all sorts of different things inside of it. And in this one, we're putting a vector. So remember that a vector has 1, 2, 3, 4 numbers inside of it. And this one, we're going to keep track of the first two vectors, the x and y values. And we'll do maybe, I guess it'd be good to do a little practice with just some simple ones of those two. The setup is pretty simple. We're just giving the canvas some size and putting in a white background. Okay, now in the draw loop on lines 15 and 16, some weird things are going to happen. Okay, now you remember from earlier processing sketches that computer graphics treat the top left corner of the screen as the origin. So if you were to put in something with a height of 0 or a position of y equals 0, it goes to the top. But we don't want that when we're doing graphs. We want things to look like graph paper without having to turn our heads upside down. And so these first two lines on 15 and 16, it says translate 0 comma height. That is going to let us basically put things at the bottom of the screen. And then after that, you see the command scale 1 comma -1. And we can actually, you can use this command to scale things in other ways too. You can stretch things out or compress things. But in this case, all we're doing is we are flipping the vertical, which basically means that as you increase the numbers in the y, you're going up, which is nice for a change. All right, and then we have this for loop starting on line 17. We're going to iterate over every pixel in the canvas all the way to the full width of the canvas. And we're going to set, okay, we have this value y. We're going to set it equal to m times x plus b. And we have all of those things already, right? And the next thing we're doing is we're just going to draw a point at x, y. Right, so we should have a point right now at, let's back up to y equals mx plus b. So we have a point at x, y. Well, x started out at 0. We haven't done anything to it. And y is going to be 0. So we should have a point at 0, 0. Okay, so we're drawing a point at the bottom left corner of the screen. And now things are going to start to get really interesting. And then we say, if x modulo 25 is 0, add a new vector, or p vector, it means processing vector, xy. And that's going to add that vector, xy, which is just keeping track of our xy coordinates, to our data table, which is called table. All right, so every time x is increased by 25, basically, we'll add a data point. And then we come out of that if statement, and then we increase x to start moving across the screen. But remember, we're still inside the for loop here. All right, and so then we're going to go, just another pixel, another value of I, and say, okay, y is mx plus b, but remember this time x is 1. And so now it's going to say, okay, y is 1 times 1 plus 0, so y is 1. Okay, and then there's a point xy, so it's going to draw a point at 1, 1, still very close to the bottom left corner, but not exactly at it. And then let's check against this if statement, and if x modulo 25 is 0, well, let's see, 1 divided by 25, the remainder is not 0, so we do not enter into that if statement. So we pass by that, we do not add a data point to the table, and then we go on and we increment x one more, and then we continue on that for loop. Okay, so the point that I want to make here is that we're not going to enter another data point until x equals 25. And the reason I chose 25 is that if I divide 500 by 25, I get 20 boxes. And if you look over there on the left on the canvas, you can actually see there should be, I hope, it looks a little bit weird right now, but there's 20 boxes on there. For some reason, one of the lines didn't get drawn. Starting at 0, 0. Okay, so there we are, just drawing those rectangles and creating a data table. And now, just like in some of these other videos, I want to leave that data table alone. I don't want to start playing with it or modifying it while I'm using this data. I just want to leave it there so that we can look at it later. We can do some calculations with it, but let's not modify it inside that loop while we're generating it. Let's just leave that loop be. Okay, so then we're going to come down into that second for loop there. And now we're going to use this to draw the rectangles. All right, so remember our first loop, we made the data table, and now we're going to start using it. All right, so now we're going to loop through the whole table, and you'll see in line 28 it says for int I equals 0, I less than table.size. That is going to iterate the for loop over every value of I in the table. I'm sorry, every index I. And so what I'm doing then is I'm saying, okay, these new values, box x and box y, we're going to have to use the table.get method. And you'll notice that it says table.get parentheses. It's not a bracket, and then it's .x. This is a notation you'll get used to. The get parentheses method gets you something out of an array list. You'll get used to using that. The indexing is different. You just call things out of it differently than you do for a normal array or a list in Python. And then the .x, that's actually built in too. The p vectors have a .x and a .y and a .z notation, and that's because they're just expecting you to have either 2 or 3 dimensions in there, or 2 or 3 numbers. Okay, so box x is table.get I.x, and that box y is table.get I.y, right? And then you see I've done a print line, and that's just to check everything out, right? I wanted to make sure that I was getting all the right values at, and I'll admit, the first time that I coded this up, everything was off by 1, right? The y values didn't match up exactly, and that was, not too bad. We got it going, but now we've moved on. Okay, and then I'm using the rectangle function to draw rectangles at box x, and then y is 0, and then the width of these boxes is all 25. This seems like, having that number 25 there, that seems like a good place to use a variable. I didn't do that. Let's see. I would probably if I were going to assign another thing to you in this project, I would say make an equation up at the very top that uses the number of rectangles and the size of the canvas to create a variable that just keeps track of the width of these rectangles automatically so that you don't have to hard code it every time. Okay, so that actually might be a good thing for you to do too. And then you see me using box Y for the height, right? And so box Y, it starts at 0. So there is a box that it starts at the bottom left corner, but its height is 0 there, so you can't see anything. Okay, so there is actually 20 boxes on there, despite it looking like there's, 19 and a half or something. There's that weird vertical line there that's just not playing nicely. Okay, and then finally, you see the command no loop. Processing is a little bit weird in that it really wants to do loops all the time, and we don't want to do that. We just want to use the built-in commands, and we just want to go through this whole thing one time and do all these calculations one time. Okay, so your assignment, and this is an exciting one. I want you to use the box X and box Y variables and get the total area of all the rectangles underneath that graph. Okay, so I want you to get the total area there. If you're feeling like, okay, if that goes well and everything goes great and you're feeling confident, try to cut the width of the boxes in half. So instead of having 20 rectangles, you would have 40. All right, that should give you much more accuracy and much closer to the area of a triangle, which you could just calculate knowing that the corners of that triangle there and the 1/2 base times height. All right, so the first assignment is just the rectangle area there using, you could probably do it in that second for loop, or you could make a new one. Nope, sorry, those variables only exist in that second for loop. So you'll have to do it in there. And then for the bonus extra cool points, go ahead and double this number of boxes and get a better estimate. And then you are well on your way to basically deriving all of calculus. Well, all of second semester calculus. All right. Good luck with this one. I hope it's challenging and fun. I'll see you later.